Okay, this is about properties of logarithms. I'm going to try to cut this video up into make two videos so that it's not extremely long. But it'll take two videos to get through the one worksheet. So at the top of your worksheet, you have a summary of the properties of logarithms. We've already talked about some of the basic ones on the last video. This one is about, we're going to look at the product rule, the quotient rule, and the power rule. So basically the product rule, product means multiply, means that if you've got the logarithm of two things being multiplied, you can separate that into separate logarithms by a plus sign. Log base a of m plus log base a of n. If you have the logarithm of something being divided, a quotient, something being divided, a fraction, log base a of m divided by n, you can separate that into two separate logarithms like this, log base a of the numerator minus log base a of the denominator. That's known as the quotient rule. And then also, if you have the log base a of m raised to some power p, what you can do is throw the power in front. You can take this little power and you can throw it in the front and it gets multiplied on there. This is equal to p times log base a of m. That's the power rule. And so these are lined out for you on your sheet. Let's just start down the exercises. It says express as a sum. Let's do this one. Express as a sum. And so the first one that I give you guys to do is this one. Log base 2 of 8 times 64. And the second one that I give us to do is log of 0.2x. And the third one that I give us to do is the natural log of a times b. Now, if they do not write parentheses around the log expression, you can do it yourself. So this is right here, that is the log expression for number 2 that they gave me. They didn't write it, but this is the log expression of AB. Okay, here we go. Let's see, what can we do here? They want me to express this as a sum. A sum means plus sign. So if you look at the rules you're allowed to use, look for a plus sign. And so we find it with the product rule right here. This has the plus sign. What has to happen to use a plus sign? You have to have a log of two things being multiplied. We have two things being multiplied here. So let's rewrite this. This is equal to log base 2 of the first thing being multiplied, 8, plus log base 2 of the second thing being multiplied. We're going to come back and simplify this a little bit, but basically we have done that. We've expressed it as a sum. Let's do number 2. This is equal to log, what's the base here, by the way? The base here is 10. How do I know that? I don't see one. It's understood to be 10. It's the common logarithm. Log base 10 of 0.2 plus log base 10 of the second thing, x. Right here, what base is this? This is base e. What's being multiplied? A times b. I can rewrite this as the natural log of a plus the natural log of b. So I've done what they asked me to do, rewrite them as sums. Sometimes you can simplify these guys. So this one can be simplified. The reason is I can rewrite 8 into the base 2 raised to a power. Think about 8. 8 can be rewritten as 2 to the third power. So I'm going to use that fact and simplify this. So if it's possible to rewrite your argument into the base to a power, let's do that. This is the log base 2, and I'm going to rewrite 8 as the base as 2 to the third power. All right. Let's see, 64. Can I do anything with that? This is the log base 2. 64, let's see, 2 to the third is 8, so 2 to the fourth is 16. If I multiply that by another 2, it's going to give me, let's see, 2 to the fourth is 16, 2 to the fifth is 32, and 2 to the sixth is 64. Okay, so I could rewrite this as 2 to the sixth. Okay, now I want to bring your attention to the properties that I labeled inverse properties. Okay, this is what this says. If you've got log base a of a to the x, this just equals to x. Or if you've got a raised to the log base a of x. This just equals to x. These are known as the inverse properties, and that's on your sheet right there. So this is what we've talked about inverses in this class, and one of the features of inverses is that when you apply an inverse and a function together, or a function in their inverse, either order, it totally undoes the process. They undo each other. So what's happening here, logarithms and exponential functions are inverses of each other. They undo each other. So if we have the log base a, this logarithmic function, being applied to an inverse function, exponential, a to the x, these are undoing each other. That's why we end up with x. Or vice versa. If we take an a raised to the something, this is an exponential function being applied to its inverse, logarithm, a raised to the log base a of x. These are undoing each other, and we just get out x. So over here, log base 2 of 2 to the 3 looks very, very much like log base a of a to the x, and this just equals to x. So if I say log base 2 of 2 to the 3, this is just going to equal to 3 right here. Log base a of a to the x is x, so log base 2 of 2 to the 6 is just 6. This can be simplified to the number 9. That's kind of nifty. Okay, let's go on to the next thing that they asked us to do, which was to express as a difference. Let's express this as a difference of logarithms. So a difference is subtraction, right? A difference is subtraction. So let's do this. Let's rewrite this as the difference of two logarithms. All right. Express as a difference goes like this. Express as a difference. Okay, the first one I give us to do is log base a of 76 over 13. And then we're going to look at the natural log of a over b. And then we're going to look at log base b of 3 over w. Okay. Expressed as the difference, let's do that. This is a fraction. Which one of these laws has a fraction? It's this one right here. And it's the one that has a difference in it. So log base b of a numerator divided by a denominator is the same thing we have here. So we can apply this. Log base a of 76 over 13 is equal to log base a of the numerator minus log base a of the denominator. We did that one. Okay, ready? Right here. The natural log of a over b. This is a quotient, a fraction. Let's rewrite it as a subtraction of two things. The natural log of the numerator minus the natural log of the denominator. The third one, log base b of a fraction, 3 over w. This is the log base b of 3 minus log base b of w. So that was all we had to do for that. Let's go ahead and do the next one, express as a product. So when we express as a product, this is what I gave us to do that. As a product. Product means multiply. Say, okay, so what is going on here? Let's just see what kind of problems I gave us to do. It says that the log base a is a product. Okay. Number 1, log base a of x to the 4, 2. Log base b of q to the negative 8. The natural log of y to the 3rd. And the natural log of the square root of a times b. Okay. After this one, we'll stop this video so that we'll cut it up into 2 videos. So right here, express as a product. This is all I have. What can I do? Well, this is where we're going to use the power rule. The power rule says if you've got log base a of m to some power, this is equal to, if you throw the power in the front and multiply it on, make it a product, p times log base a of m. That's equivalent. All we're going to do is take this little power 4 and throw it in the front. This is going to become 4 times the log base a of x. Done. Right here, log base b of q to the negative 8. Take the power, throw it in front. This is negative 8 times the log base b of q. And if you don't, this is understood to be multiplied, but if you want to put a little dot, If that makes you feel better, that's just fine. Let's rewrite 3 as a product. Take the power, throw it in front. 3 times the natural log of y. Done, done, done. That's pretty easy. Now we have this guy. So I want to just talk about this. This is something you learned in intermediate algebra, but maybe you didn't spend a lot of time on it. Radicals are powers. They are fraction powers. So for instance, if I have the square root of x, this is equal to x to the 1/2. If I have the cube root of x, this is equal to x to the 1/3. If I have the 5th root of x squared, this is equal to x to the 2/5. Here is the generic way to convert this. If I have x, let me just use x. The base x raised to the a/b. The denominator b becomes the index. This becomes b raised to x to the a. So the numerator stays with the power. The denominator becomes the index. This is how you can convert back and forth. So when you're given this logarithmic expression, you should first rewrite this as the natural log of ab raised to the 1/2 power. 1/2. And then we can very easily throw the power in the front. This becomes 1/2 times the natural log of ab. That's all we had to do for that one. All right.